Alright, so let's have a look. For this video, we'll be discussing May June 2025 paper 3.3. Okay, let's have a look for the first question. They want us to sketch the graph of y equals to 3x minus 2a modulus, where a is a positive constant. Alright, so usually when I want to sketch the diagram, I will need to find out, I would prefer to find either the x-intercept or y-intercept. Okay, so when I've been having this one, maybe I will let x equals to 0. Then what's the value of the y that I get? I get y equals to modulus negative 2a, and it should be equals to 2a. Alright, then when I let y equals to 0, what's the value of x that I have? I'll be having x equals to 2a over 3. And let's plot the graph now. You can assume that the a is a 1, right? Then it's easier for you to sketch the diagram. So for x-axis, I will have, this is the a, 1 over 3a, 2 over 3a, then 3 over 3a. After that, I'm having 2a here. And the rest, okay? Then for the y-axis, also the same thing. I will be having a, then 2a. Then if you want, you can continue further. Alright, so it depends on what is the point that you are having and you want to plot them. Okay, then after that, we are having the x and also y axis here. Okay, just now we already found the intersection point, the point on the graph, right? So x equals to 0, y equals to 2a. This one. This is a point. Then when y equals to 0, x equals to 2a over 3. So 2a over 3 will be somewhere here. Okay, then for me, maybe I try to also substitute another value. Maybe I substitute x equals to a. If I'm having x equals to a, then what's the value of y that I have? I will be having 3a minus 2a, which is equals to a. So that means I'm having another point is here, a and a. Then you try to join the point together. So it basically it will look like a V shape, right? So this is what I have. So you try to draw the line nicer, yeah? You use a ruler to connect the 2 points together. And this is how your graph should look like. Alright, then don't forget to label this as 2 over 3a. Okay, and this is particularly what you have for y equals to modulus 3x minus 2a. Right, then let's continue to part B. Hence or otherwise, solve the inequality for this. Alright, so for this question, you have one side with the modulus, the other side has no modulus and with the x one. And usually to solve all this inequality, I would prefer to find out the critical value first. Critical value means the intersection point first. Right, so for the modulus function, you're having two parts of the answer, of the equation. First part is the original equation, 3x minus 2a. Another part of the equation is the refracted part where it will become negative 3x minus 2a. So I try to figure out the intersection point for these two curves first. So I'm having 3x minus 2a equals to x plus 5a. Then another one is negative 3x minus 2a equals to x plus 5a. Okay, then from here we try to solve it. I'm having 2x equals to 7a, and therefore my x will be 7 over 2a. Then for this one, I will be having negative 3x plus 2a. And when I further simplify it, I will be having negative 3a. Then x will be equals to negative 3 over 4. I will call this as the critical value. That means it is basically the intersection point, the possible intersection point for these two curves or these two equations. Right, then after that, I had to decide at where or which is the range of the x so that the inequality is fulfilled. Alright. Okay, so what should we do is like we have to check our answer part by part. Okay, I'm having negative 3 over 4a. Then I'm having 7 over 2a. Okay, then I separate into a few parts here. There are 3 parts here. First part, second part, and 3 parts. So I use the critical value to help me and check the answer part by part. Okay, so for this part, Choose any value that's smaller than negative 3a over 4. So I will use x equals to negative a. Substitute x equals to negative a into your inequality, then you'll be having modulus negative 3a minus 2a smaller than 5a. Sorry, it should be smaller than 4a, right? Because negative a plus 5, so it should be 4a. Alright, then you're having 5a modulus. Negative 5a modulus become positive 5a, smaller than 4a. So you realize that this is not the correct inequality. That means the answer from this part will not give you the correct inequality that you want. Then for the second part, now you choose. You have to use maybe some other value. You use x equals to, is there any value between negative 3 over 4 until 7 over 2? Yeah, I think 0 is the easiest one, right? Okay, then again, you are having modulus negative 2a smaller than 5a. And you are having 2a smaller than 5a. And this inequality is a correct inequality. Therefore, that means the answer from this part will give you the correct inequality that we want. Then for the last part here, also the same. You try to use any value greater than 7a over 2. 7a over 2 means 3.5a. Then maybe you can use 4a, easier. The whole number 4a. Okay, substitute inside. 4 times 3 is 12. So 12a minus 2a modulus smaller than 9a. So 12a minus 2, you're having 10. 10a smaller than 9a. Is it correct inequality? No, right? This inequality is not true. Therefore, it is not correct also for this part. And from here, you can see that only the answer from this part with the value of the x from this part will give you the correct inequality. Therefore, the correct final answer for our question is negative 3 over 4a for the x, but it is less than 7 over 2a. Alright, so this is how we solve question number 1. Question number 2. Solve this equation. And the equation involves the ln. Okay, it means that we have to basically use a few important properties on ln, about the ln. Okay, if let's say I'm having n ln x, then you should know that we can change it become ln x power n. Okay, then what else do we have? If let's say I'm having ln a plus ln b, basically you can combine that and become ln a times b. Then if you're having a minus 1 ln a minus ln b, then it will become ln a divided by b. Okay, and one more thing, if let's say you're having ln something equals to ln something, then only you can simplify and cancel off the ln. If let's say you're having ln something equals to ln something plus something, then you cannot just cancel off like that, yeah? Alright. Okay, so let's start with the equation that we have here. 2 ln 2x plus 3 minus ln 2x plus 5 is equals to ln 3x. Okay, what I want to do here is I try to make the 2 become the power. Okay, when I make the 2 become the power, right, it will become 2x plus 3 squared. And you see this minus, right? I want to combine these two terms together become 1 ln. So it is a minus, therefore I have to divide it by 2x plus 5. Then equals to ln 3x. Okay, both sides here you can see that you have ln something equals to ln something. That means you can cancel it off straight away. Then I expand. I want to get rid of the denominator. So what I do is like I expand the numerator on top. Then I bring the denominator over and expand it. So I will be having 6x squared plus 15x. Alright, then try to rephrase the equation here. I think it's quite obvious that we'll get a quadratic equation. Then you can try to factorize this quadratic equation and solve them. We are having 2x minus 3, then x plus 3. So x equals to 3 over 2, and also x equals to negative 3. But for this negative 3 value, we have to ignore it as the final answer. Do you know why? Why do we need to ignore this and accept only the answer x equals to 3 over 2? Okay, when we are trying to solve all the equations that involve the ln, right, you have to take note that ln, the value here inside the ln must be a positive value. It cannot be negative because ln negative value will give you a mass error. If you substitute negative 3 into this part, let's say like as an example, then you'll be having ln negative 9. So ln negative 9 will be a mass error. Therefore, you can use this as a final answer. So when you solve any question with the ln, please make sure that you double check your final answer first. Alright? Yeah, so this is how we solve question. Question number 3. Find the exact value, highlight the keyword exact of this integration. Okay, so what is the technique that we should use to integrate this particular term here? We are having 3 cos square 5x. Alright, we need to know that when you want to integrate any cos function, right, with power 1, then you can integrate it directly. But when we are having cos square or maybe sine square, right, then basically we have to use the double angle formula. Alright, then the double angle formula will be for cos, so we have to use this one, cos 2x. There are 3 possible answers for cos 2x, right? You are having cos square minus sine square, 2 cos square minus 1, then 1 minus 2 sine square. And because of this question, we are having the cos square in our equation, so I'm using the cos square formula. So cos 2x equals to 2 cos square x minus 1. Okay, so this is the identity that actually link the cos power 1 with cos power 2. Although the angle here is different, it's double angle, right? Okay, but I know that when I'm having anything with cos square, if I apply this formula, I can reduce the power of cos become the 1, right? But now the problem is I'm having cos square 5x. In the formula here, I'm having cos square x only. And now, to apply it in our calculation here, what I want to do is that I want to modify the angle, become 5x. Just now it's x, right? So you can change it become 5x so that it is similar to what we have in the question. Just now we are having x here, then the double angle here is 2x. If now I'm having 5x, what happened to the double angle here? It will become 5 times 2 and it will be 10x. So for any identity integral, you are allowed to modify the angle in this way. Okay? Then after that, if I try to rephrase my answer, my equation, I'll be having cos square 5x equals to 1 plus cos 10x divided by 2. And that means I can substitute this one into my equation for integration and to solve it from there. Right? Okay, I'm having pi over 4. I'm having pi over 5. Then 3 cos square 5x dx. 3 is a constant. I always prefer to take it out first. I left only cos square 5x in the expression. And like what I told you just now, cos square 5x can be written like this. So I'm having half. Then 1 plus cos 10x. Okay, so again, before I start the integration, I still prefer to take out all the constant. Integrate the 1, I'm having the x. Integrate cos, I'll be having sine. So sine 10x. Differentiate the 10x, you get a 10, right? So I have to divide it by the 10. Then I'm having pi over 4 and also pi over 5 here. Then please substitute in the value now. For pi over 4, I'm having pi over 4. Okay, 1 over 10, I just copy it at 1 over 10. Sine 10x, so 10 divided by 4, you'll be having 5 pi over 4. Sorry, 5 pi over 2. After you simplify it, 5 pi over 2. Minus, substitute in pi over 5 into the x. Sine 10x. 10x means there's 10 multiplied with pi over 5, and you're having 2 pi here. Okay, so for the term with the pi over 4 and pi over 5, so you take pi over 4 minus pi over 5, you'll be having 1 over 20 pi. Pi over 20, I would say. I simplify the term with the pi first, yeah? So pi over 4 minus pi over 5. This is what I get. Then for this one, what's the value for what's the value for sine 5 pi over 2? Sine 5 pi over 2 will give you a value of 1. You can use calculator to help you basically. Then for this one, sine 2 pi will basically give you a value of 0. Okay, and now from here you can see that we are having 3 pi over 40 if you multiply inside, and also 3 over 20. Yeah, so I think this will be our final answer for the integration of this. Okay, and since they're asking for exact value, so you can see that we basically put it in terms of the pi. Alright, yeah, so this is how we solve question number 3. Alright, so we are now at question number 4. We are given the complex number in the exponential form, z1 and also the z2. And they want us to show that z1, z2 conjugate equals to z1 conjugate multiplied with z2 conjugate. Alright, so first of all, let's understand a little bit more about the exponential form in the complex number, and then also about the conjugate. Alright, okay, when I'm having any complex number, right? Okay, let's say I try to make it in this way. I draw an Argand diagram. Then I have a real part and also the imaginary axis, right? Okay, when I'm having a complex number z, where the x is the x value and the y is the y value, okay? Then when I write this complex number z, the Cartesian form will be x plus yi. Correct? So when I write it out, it should be z equals to x plus yi in the Cartesian form. But at the same time, if you try to figure out the length of this complex number z, I will represent it by using the r. R is the modulus of the z. And then the argument for the z is this one. I measure it from the positive x-axis and then I have a theta. So there's another way for us to write out the z in the complex number in the exponential form, where it should be r, then multiply with e, I theta. So how to get the exponential form for the complex number? Basically, it is also from the argument modulus form. So if you're interested, please go and search argument modulus form for a complex number or modulus argument form of a complex number, then how they link that pattern into the exponential form. But for now, I'm not going to explain in detail about this. I just want to let you know that for a complex number z, if let's say it is in the first quadrant, then the z Cartesian form will be x plus yi. And then when you're having the z in the exponential form, it will be r, then e power I theta, where the theta is the argument for the z, and then r is the length for the z. Okay, then now we want to investigate what happened if let's say I want to make it into z conjugate. When you are having the z conjugate, the star here means conjugate, yeah? So z conjugate means that basically you have to make the sign of imaginary part become the opposite sign. So as an example, if I'm having x plus yi, then if I make the yi become negative, then I will be having the x conjugate as x minus yi. Okay, then for x minus yi, if you try to draw it on an Argand diagram, then the x is the same, but now the y will become negative y, right? So x minus yi, and your exact conjugate will be here. This one. So this is a z conjugate. Okay, then at the same time also, when you try to figure out the length for the z conjugate, basically it is the same as the z modulus of z, and the modulus of z conjugate should be the same, which is the r as well, right? The length is the same. Okay, because x squared plus negative y square root still the same like this one. X squared plus y square root. Then how about for the argument? So for the argument, I have to measure it in clockwise direction. The angle basically is still the same, but because we measure it in the clockwise direction, therefore you have to put a negative in front of the angle or in front of the argument. Therefore, if I want to put z conjugate into the exponential form, all right, so what we have here is we are having r, then theta multiplied with negative, re, then power negative I theta. Alright, so this is how we write out the z in Cartesian and also the exponential form. The other one will be z conjugate in Cartesian and also the exponential form. So the theta become negative theta because of we measure in the clockwise direction. Is it clear? Then maybe some student will ask, then how about if let's say I'm having my z in other quadrant? Basically, the idea is the same. Okay, so as long as you are having the z conjugate, then the theta here will become the negative theta. Right? Yeah, maybe you can try out some other quadrant. Let's say your, as an example, if let's say your z is in this quadrant, okay, then when you have z conjugate, you will have the z conjugate in this quadrant. So basically, it is still the same, theta and negative theta. Same thing happen for this third and fourth quadrant, second and third quadrant as well. All right. Yeah. So I just want you to have a look and try to compare the exponential form for the original z and also the exponential form for the z conjugate. All right. Then now let us try to show this one. I will want to start from left hand side. I'm having z1 multiply with z2, then the conjugate of it. So first of all, let's figure out what is the z1 multiply with z2 first. I'm having r1 e I theta 1 multiply with r2 e I theta 2. Then I want to have the conjugate for it. Okay, so before I make it become the conjugate, I try to group all the r together first. I'm having r1, r2, then e. Factorize out the I will have theta 1 plus theta 2. Because when you multiply the e power something, also with e power a multiply with e power b, you are adding the power together, right? Yeah, so this is what you have. Then after that, how can I make the conjugate here? So you assume that this whole thing is a complex number and I want to find out the conjugate in the exponential form, same like this one. Z, when you want to change it become a conjugate, you change the argument become negative sign. So when I want to get rid of the conjugate here, I will put a negative sign for my argument. Okay, so this is what I showed you just now. Then after that, they want us to show that it can be written as the Z1 conjugate and Z2 conjugate. That means now I want to separate them again. I try to separate out the E first. I will be having E power negative I theta 1, then E minus I power minus power negative I theta 2. Okay, because you multiply the negative inside, right? Then when you try to expand it, this is what you will get. Negative theta 1i plus negative theta 2i. Then from here, what do you get? You group all the I1, R1 and also the theta 1 together. So you'll be having this. Then multiply with R2, E negative I theta 2. So let's have a look for this part. So this one, basically, it is the conjugate of Z1, complex number Z1, right? Therefore, for this part, I can write it become Z1 conjugate. Then for this particular part here, again, you're having R2 E negative I theta. Your original Z2 is E I theta 2, no negative. But this one got negative 1, right? So I can write this as theta, I should write it as Z2 star. Okay, so this is how we solve question 4a. Right, then let's continue to question 4b. Now they give us this complex number with the modulus 3 and also the argument pi over 4. Then they say it is the root of the z squared plus bz plus c equals to 0, where b and c are real. State another root and hence find the values of b and c. Okay, if I know that this is one of the root, yeah? Okay, so let's have a look first. 3e power pi over 4i. If I want to change it become the Cartesian form, it will become 3 multiplied with cos theta plus I sine theta. Alright, then what's the value for cos theta and I sine theta? Cos theta is square root 2 over 2. Then I sine theta is also the same, 3, then sec 2 over 2, then I. So from here, you can see that one of your root is actually 3 sec 2 over 2 plus 3 sec 2 over 2i. This is the first root given in the question. But I just try to show them in the exponential form and also the Cartesian form. And now they want us to state another root. To state another root, you can have a look for the equation that we have. They said that this is the equation. It is the root of this equation and the coefficient of the equation are all real because z squared is a 1. 1 is a real number. B and C, although it's unknown, but I know that they are real as well because it is mentioned in the question. Therefore, according to the property that we learned, when all your coefficient in the polynomial is real, then the root will appear in conjugate pair. This is one of your root. Therefore, the other root will be the conjugate of this first root here. So other root will be what? So the other root will be 3 sub 2 over 2, then minus 3 sub 2 over 2i. Of course, if you want, you can put it into exponential form also. The conjugate for the exponential form will be 3e power negative pi over 4i. This is the answer for the other root. Okay? They are coming in conjugate pair because all the coefficient of the polynomial is real number. Alright, then after that, they're going to find the value for b and also the c. How to find the b and c? Again, first of all, let's write out the equation again. It is a quadratic equation. Z squared plus bz plus c equals to 0. And we know that the quadratic equation basically is formed by this one. Z squared minus sum of root multiply with the z. Then the c will be the product of root. Alright, so we have two roots here. What is the sum of root? So to get the sum of root, I feel that it is easier for us to make it in the Cartesian form. So I want to add the two root together in the Cartesian form. Alright, so let's find out the sum of root. So root number 1 is 3 sub 2 over 2 plus 3 sub 2 over 2i. The second root is 3 sub 2 over 2 minus 3 sub 2 over 2i. Okay, when you try to simplify this one, you'll be getting 3 sub 2. Okay, because the 3 sub 2 over I over 2i, then this one also can be cancelled off. So you add these two terms together, by right you'll be having 3 sub 2. So this is the sum of root. Okay, then according to the equation here, b is the negative of sum of root. Therefore, b will be equals to the negative of 3 sub 2. Okay, then after that, how can we find out the product of the root? To find the product of root, I feel that it is easier for me to apply it using the exponential form. Alright, so I try to figure out the product of the root. I'll write it here. Okay, so the product of root, you're having the two roots here, right? So how you multiply them together? You're having, first root is 3e power pi over 4i. So 3e power pi over 4i. The other one will be this one, 3e power negative pi over 4i. Okay, please multiply them together. You'll be having 9. 3 times 3 is a 9, right? When you want to add these two power together, e power a multiply with e power b, that means you are adding the power together. You're having pi over 4i minus pi over 4i. So e power 0, what do you get? You get a 1. Therefore, your final answer for the product of root will be the 9. Okay, then if you try to compare product of root with the equation here, the c is equals to the product of root. Therefore, you know that c is having the value 9. Okay, so this is how we get the value for b and c. Alright, so for you, some of you might use some other method. As long as you can get the correct value here, then basically the method will be accepted. Because some students might substitute the value inside the equation and try to solve them also can. Alright, yeah, so there are many possible ways. So this is just a suggestion. Alright, and this is how we solve question number 4. Question number 5. We are given the equation, and then they want us to show that dy dx equals to the expression that they want us to show here. Okay? Right, so there's a mixture of x and y in the equation, and definitely we cannot separate the x and y clearly, where I cannot make it into like y equals to something something x here. Right? Therefore, we have to apply implicit differentiation. Okay, so let's have a look for the first term of xy first. So xy basically means that x multiply with a y. So when you want to differentiate it implicitly, you have to treat it like a product rule, where x is the first bracket, y is the second bracket. Alright, then copy the first bracket, differentiate the second bracket, differentiate y. What do you have? You have a 1. Then you have to put the dy dx at the back because you are differentiating y in with respect to x. Okay, so this one is copy the first bracket, differentiate the second, and now you want to copy the second bracket, differentiate the first. So differentiate x will be having the 1. By right, you should be having dx over dx. That means you differentiate x with respect to x. Okay, but dx over dx, usually we didn't write it out because it will be equals to 1. Then plus. Same thing happen for the second term here, y squared e power negative x. Copy the first bracket, differentiate the second. I will have original equation, original expression e power negative x, then multiply with the differentiation of the power, which is negative 1. Then plus. So just now you copy the first, differentiate the second, right? And now you copy the second bracket, differentiate the first. So differentiate y squared, you will be getting 2y. And of course, you have to put in dy dx. You are differentiating y with respect to x. Okay, then differentiate a 4, you'll get a 0. Alright, then to get the dy dx, what I need to do is that I group the term with dy dx together. So I will be having x, then plus 2y e power negative x. And then I move all the term without the dy dx to the other side. Then I will be having y squared e power negative x, then minus the y. Okay, then after that, bring all the other terms to the right hand side. And this is what I get. I will be having y squared e power negative y minus y. Minus x, then minus y. Divided by x 2y e power negative x. But if you try to compare what we get here and also compare with what they want us to show in the question, in the question they don't have any e power negative x, but they're having e power x. So you have to think a way how to make the e power negative x disappear here. Alright, so we're having 2 e power negative here, right? If you rewrite again, you will be having 1 over e power x. Same thing happens for this one, you will be having 1 over e power x. And to get rid of the fraction inside the fraction, you need to multiply e power x both top and bottom. Okay, so the e power x multiply inside here, multiply it here. Same thing happen for the denominator, multiply it into the both term. Then when you try to rewrite the answer again, you will see that we will get the pattern that they want us to show. Okay, so we're having x e power x, then plus 2y. This is how we get the differentiation. And this is, we are applying implicit differentiation. It belongs to part of the chapter 4. Alright, okay. Then let's continue further to part number B. Now they want you to find the gradients of the tangents. Highlight the keyword gradients. You can see the S here. That means you might have more than one answer here. To the curve when x equals to 0. Alright, gradients means dy dx. So they want to know the value of dy dx, yeah, when x equals to 0. Okay, if you have a look for the dy dx that we get just now, right? They are x and also the y. So to get the value of dy dx, you need to get the value for y first. And now we only have the value of the x. Okay, so let's substitute your x equals to 0 into the original equation to get the y. Alright, okay, so let's start. When x is equals to 0, I substitute it into my original equation where it should be 0 multiplied with y, then plus y squared e power negative x equals to 4. Okay, so the negative x here, it will be e power 0. So what's the value for e power 0? It is basically equals to 1. Therefore, your y is plus minus 2. And you're having two pair of the point. One pair is you're having 0 and 2. Another point is 0 and negative 2. When x is equals to 0, y equals to 2, what is the value for your dy dx? Substitute into your dy dx equation just now. Okay, so you'll be having, okay, so let's recall again. What is my equation for the dy dx? in part A. So part A, we will be having y squared minus ye power x divided by xe power x plus 2y. Okay, now your x is equals to 0, your y is equals to 2. So substitute inside, you'll be having 4. Y squared is a 4 minus 2. E power 0 is a 1 divided by xe power x is a 0 plus 2y is a 4. When you simplify it, you will get the value half. This is the first value for the dy dx. And since we are having another point, alright, so at another point, what we have here is we are having 0 and also y equals to negative 2. What's the value for the dy dx here? Again, substitute negative 2 inside, negative 2 squared, you get a 4 minus negative 2. E power 0 is a 1 divided by 0 multiplied with anything is a 0 plus 2 multiplied with negative 2. So you'll be having 6 over negative 4. And the value that you get for dy dx should be equals to negative 3 over 2. Alright, so this is the values for the gradients of the tangent. Alright, and this is how we solve question. Question number 6. Find the complex number z for which this one is real. Okay, and also the modulus z is equals to square root 10. Give your answer in the form of z equals to x plus yi, where x and y are real. Alright, we know that x is a complex number, right? And it is written as x plus yi. I want to use the very first information here first. Modulus z equals to square root 10. Right, if let's say z is equals to x plus yi, then the modulus will be equals to square root x squared plus y squared, right? And since it is given that modulus z is equals to square root 10, therefore you're having square root 10 equals to square root x squared plus y squared. Then from here you will get one equation with two unknown, x squared plus y squared equals to 10. And I will make this as the first equation. Alright, after that we need a second equation, then so that we can solve it simultaneously to get the answer for the x and y. Where can I get a second equation? We can get it from here. Alright, so I just want to mention again, this question, right, is very similar to one of the question in May-June 2025 paper 3-1. Okay, in that video, I actually discussed two methods to get the second equation here. Alright, so if you are interested for the both method, you can go to that video and have a look. But for me, for this video, I will only discuss one method where I found is more convenient one. So in this video, okay, I did discuss both. Alright, so if you're interested, then you can have a look. For me, one of the method is too tedious, so I don't really like. So I prefer to have the easier one here. Okay, yeah, so just take note on this, yeah. Alright, and when they are talking about z plus 4 divided by z plus 4i is real. Real means that it will become, your complex number will become something like k plus 0i. That means the imaginary part is a 0. Alright, I'm going to use this information and try to form the equation. From here, I'm having z plus 4 divided by z plus 4i equals to k plus 0i. Okay, so what is the value for z plus 4? Z is actually x plus yi. Then, for the z plus 4i, it will be equals to x plus yi plus 4i equals to k. Okay, then I want to get rid of the denominator. I try to move it to the right hand side. And I'm having k, x, then plus ky plus 4 with the I. Okay, then usually in a complex number, right, we can compare real part with the real part. So I'm comparing this one with the real part here, real with the real part. And what do I observe here is I'm having kx equals to x plus 4. Then k is equals to x plus 4 over x. Then if I try to compare imaginary part with the imaginary part, I'm comparing the y together with ky plus there's a careless mistake here. Do you aware of it? I have to multiply the k inside the 4 also, right? So you should be having 4k here. Okay, so I need to compare imaginary part with the imaginary part. Therefore, I'm having y equals to ky plus 4k. Okay, then from here, I can rephrase also k in terms of y. So I'm having k equals to y over y plus 4. Okay, when I try to compare real part with the real part, imaginary with imaginary part, I get a common equation in terms of k, with the k, right? So it also means that x plus 4 divided by x equals to y over y plus 4, because k should be equals to the k, right? So this is what I get. Then I try to simplify this equation. Okay, so from here, what do we get? I cancel off the xy with the xy here. Then I group my x plus y on one side. Then the other side will become negative 4. Because I divide all my terms here with the 4, then bring the positive 4 over, become negative 4. And from here, I get my second equation, where negative 4 negative y is equals to the x. And this will be my second equation. Alright, so for me personally, I feel this one is easier than the other method where we try to rationalize the complex number one. This is what I feel like, alright. But if let's say you found that rationalizing is easier for you, then of course you can proceed with the rationalized method, right? Okay, then since I get the second equation already, and I have the first equation, therefore I need to solve them simultaneously to get the answer, to get the value for the x and y. Okay, so can I just put it in this part? Alright, so I want to sub equation number 2 into equation number 1. Okay, I will be having negative 4 negative y squared plus y squared equals to 10. I will have 16 plus 8y plus y squared equals to 10. Alright, group everything together at one side because I already can see that it is a quadratic formula. It is a quadratic equation. Alright, y squared plus 4y plus 3 equals to 0. Factorize the y. 3 and 1, positive both. Then you will get two values for the y, where y equals to negative 1 and also y equals to negative 3. Then again, I want to get the value of the x, right? Try to use the linear equation if you can. So I want to use this equation to find the value of the x. Substitute negative 1 inside, you'll be having negative 3. Then for this one, if you substitute negative 3 in your equation, you'll be having negative 1. Alright, then for me, I usually prefer to rewrite my answer one more time. So what is the possible complex number for the z? You'll be negative 3, negative I. Or another answer is z can be also negative 1, negative 3i. So this is how we get the complex number z. Okay, and this is how we solve question number 7. We are given a rational function, and then a is a positive constant. Express fx in partial fraction. Right, so first of all, let's check whether is it an improper fraction or proper fraction first. I'm having x power 1 on top. Then the bottom, if I multiply them together, I'm having x squared. X power 1 on top is degree 1. X power 2 at the bottom is degree 2. Therefore, this is a proper fraction. When you're having a proper fraction, you can directly separate it into the partial fraction. Okay, so I'm having 3a minus 5x. Then 3a plus 2x. 2a minus x. It is equals to, okay, separate them into two partial fraction. One partial fraction is with the denominator 3a plus 2x. Another one, it will be b over 2a minus x. Okay, then after that, I want to get rid of the denominator here. I multiply the whole equation by using the original denominator. That means I multiply the whole thing with this one. Okay, yeah. When I multiply it here, then you will be having 3a minus 5x multiply with this term, 3a plus 2x and 3a plus 2x can be cancelled off. You are having a with 2a minus x. Same thing happens for the second partial fraction. If you multiply it, you'll be having 3a plus 2x here. Okay, so this one I will take it as multiplying 3a plus 2x and also 2a minus x. Okay, right. And this is the equation I get. And now I want to slowly get rid of the a and also the b to find the a and b now. Right, so first of all, I will refer to this particular bracket first. I want to make this bracket become 0. Therefore, I have to let x equals to 2a, so that 2a minus 2a equals to 0. Okay, because all these are the linear factor, right? So this is what you can do. Okay, then after that, if you let x equals to 2a, substitute it here, you'll be having 3a minus 10a. 3a minus 10a, you'll be having negative 7a, right? Then 2a minus 2a equals to 0, your a will disappear. Then this one, 3a plus 2a, 2 times 2a will be 7a. So you're having 7ab. And your b is basically equals to negative 1. Okay, so just now I'm trying to make the first bracket here become 0, and now I want to make the second bracket become 0. So what's the value that I should let x become? So I have to let x equals to negative 3a over 2. Because if you substitute negative 3a over 2 inside this particular part, inside the x here, your bracket for this one will be equals to 0. Then you can get the value for the a. Right? Yeah. So substitute inside. Simplify this left-hand side here by substituting the negative 3a over 2 inside the equation on the left, this part. By right, you'll be having 21 over 2, 21a over 2, and it is equals to, substitute it inside this bracket, then simplify it, you'll be having 7a over 2 with the a. Simplify both equations, both sides, and then by right, your a is equals to 3. Right? Then again, I will rewrite the partial fraction one more time at the end of the solution. So 3 over 3a plus 2x, then minus 1, 2a minus x. Yeah, so this is a partial fraction that we have. Okay, all right, then let's continue to the second part, part B. For part B, they want us to get the expansion for function fx in ascending power of x up to and including the term in x squared. Alright, so let us write out the original formula first for the binomial expansion. You can get it from the list of MF 19, but for reference, I will just write it out here. If I'm having 1 plus x power n, the first term is always a 1, the second term is always nx, the third term is n minus 1 divided by 2 factorial, then you have x squared. Then of course you can continue to expand for x power 3, x power 4 and so on. But for me, I will just stop at x power 2 because in the question, they only request us to find out the answer up to x power 2. Alright, and then we're going to apply this particular equation, right, or formula. You have to always ensure that the first term in your bracket must be always a 1. Then only you can apply this formula. That's the first thing. And the second thing is you need to know what's the valid value of x. This equation is correct only when the x, the modulus of the x is smaller than the value in front. So this is the valid value for the x. Okay, and let us start our expansion here. I will want to straight away start with the answer from the partial fraction just now. I'm having 3 with 3a plus 2x power negative 1. This is my very first partial fraction. Then I'm having negative 1 with 2a minus x power negative 1. Right? Yeah, so this is my first partial fraction. This is the second partial fraction, and I want to expand that. Maybe to make it easier to identify the difference between them, I will use the purple color for the second bracket. So you'll be having 2a minus x power negative 1. Okay, so let us have a look for the first partial fraction first. The first term in the partial fraction, it doesn't start with 1. So I have to do some adjustment here. I have to factorize out the 3a and follow with the power -1. Then I'll be having 1 plus 2x over 3a, because you have taken 3a out from the bracket, right? Yeah, so the 2x have to divide it by 3a. Then you're having the -1 here. Same thing happen for the purple color bracket. You need to factorize out the 2a first with the power -1. After that, you're having 1 minus x over 2a, power -1. So that's the first step where we try to adjust our bracket into the first term with the 1. Okay, please simplify 3 over 3a. You'll be having 1 over a. And now I want to start expanding the first bracket here. First term is always a 1. Second term is nx. So my n is -1. X will be the second term. So the x will be 2x over 3a. Okay, then how about the third term? So the third term will be -1, which is the n. n minus 1 is -2. Then divided by 2 factorial. Then x squared. So the x means the second term in the bracket. So 2x over 3a power 2. Okay, so I'm done with the expansion for the first bracket. And now we want to continue with the second bracket. So for the second bracket, you can observe that 2a power -1 will give you 1 over 2a. Okay, then after that, I start expanding this one. First term is always a 1. Second term is nx. So n is -1. X is negative x over 2a for the second bracket. Third term is -1. N minus 1 will be -2 divided by 2 factorial with the bracket of negative x over 2a power 2. Okay, so you can see that for the expansion, I try to stop at x power 2 because the question requested up to x power 2 only, right? Yeah, then now we have to slowly simplify all the terms here inside. I'm having 1 over a, then 1 minus 2x over 3a. Then what is the next one? The next one will be 4x squared over 9a squared. Okay, then after that, for the second bracket here, if you simplify all the terms inside, what you get here is you will get 1 plus x over 2a, then plus x squared over 4a squared. Okay, then after that, multiply the 1 over a inside the red color bracket here. So you will have 1 over a minus 2x over 3a squared, then plus 4x squared over 9a cubed. For the purple color one, multiply it also. You will have first term -1 over 2a. The second term will become x over 4a squared. Then the third term will be negative x squared over 8a cubed. Alright, then after that, how to simplify that? Okay, so you take 1 over a means 1. 1 over a, you assume that 1 multiply with 1 over a, which is like an apple. Okay, so you're having 1 apple. Then negative 1 over 2a. 1 over 2a, you can treat it as half multiplied with 1 over a. So it's like you're having half apple. Okay, then you're having 1 apple minus half apple. So what do you get? You're having half apple, right? So the first term that you get here will be half 1 over 2a. Then you do the same thing for the rest of the term. 2x over 3a squared minus 1x over 4a squared. If you try to simplify it by right, you'll be having 11 over 12a squared, then x. Then the last term for x squared, take 4 over 9 minus 1 over 8. 4 over 9 minus 1 over 8 will give you 23 over 72. Then I'm having a cubed with the x cubed. With the x squared. So this is how we get the answer. Alright, so the step, this is basically not very hard, just that it is a bit complicated like when you see all the steps here, because you're having all the a, all the x and everything. Make sure that you try to simplify very slowly and carefully. Don't do careless mistake here. Alright, so this is what you have for part B, the binomial expansion. Okay, then let's continue to part C. For part C, they want you to state the set of value of x where the expansion in part B is valid. Okay, so let's have a look for our expansion here. I'm using the formula when I have this, right? 1 plus 2x over 3a. Okay, so let us write out 1 plus 2x over 3a power negative 1. What is the other one? Purple color one is 1 minus x over 2a. Okay, 1 minus x over 2a. When I try to write out the valid value of this bracket, it will become modulus 2x over 3a is smaller than 1. Then you just want to keep the x on the left because x is the unknown, right, the variable, but a is a positive constant. So if you move it to the other side, you'll be having 3a over 2. So for this particular part, it will be from negative 3a over 2 until positive 3a over 2. For this particular bracket, this is the valid value for the x. Then for this bracket, you'll be having modulus x over 2a. The negative, you put modulus, it also become positive, right? So I didn't write it out. Then I'm having modulus x smaller than 2a, and I have negative 2a x than 2a. But when we want to apply the binomial expansion formula in both of the bracket, right, we have to make it valid for both bracket. We always choose the smaller set of the value. So if you compare this one, it is modulus x smaller than 1.5a, and this one is modulus x smaller than 2a. Definitely this is a smaller set, right? Therefore, you need to make a conclusion here. The valid value for x is this one, the smaller set. So because the smaller set will be correct for both bracket. If you take the larger set, there are some part of the value of a does not fulfill this one, right? Yeah. And therefore, this is the answer for the valid value of the x. Right? Yeah, so this is how we solve the question number 7. Alright, we are now at question number 8. They want us to prove this identity. Okay, and since they give us left-hand side starting with cotangent square theta minus tangent square theta, then I will start from left-hand side. Okay, actually for my habit, right, usually I would prefer to start from double angle one, going from right to the left. And then I realized that usually in our question, right, most of the time when they give us something at the left, usually it will be easier for us to start from the left. But of course, it's not wrong that you want to start from the right, right? Okay, so I will just straight away start from the left first. So left-hand side, I'm having cotangent theta square, then minus tangent theta square. For these two these two trigo, right, I can write become cos and sine. I want to make it in terms of cos and sine. So cotangent theta will be cos square over sine square. Simply happen for this one, tangent square will be equal to sine square over cos square. Okay, then after that, on the right hand side, you can see that we are having only one how to say it is one term okay, although they are multiplication of a few functions, but it is in one term. But on the left, there are two terms here. So how to make the two terms become one term? We are having the fraction here. So to make it become one term, we have to combine these two fractions together. Therefore, I multiply the denominator to each other. Then I cross multiply the numerator with the denominator of the other one. So I'm having cos power 4 theta minus sine power 4 theta. Okay, so you can see that now I successfully combine two fractions become one. And how should we continue here? Alright, so you can see that we are having cos power 4 and sine power 4. To me, I think it is quite complicated. I want to make it slightly simple first. Alright, so let's recall a bit about the formula that we learned maybe in the very early stage of maths paper. If I'm having x squared minus y squared, how can we factorize it? It will become x minus y and also x plus y. Okay, but now we are having something with power 4. If let's say I'm having x power 4 minus y power 4, Then basically I can separate them, become x squared minus y squared and also x squared plus y squared. Agree? Alright. And I want to apply this particular formula, the factorization, into the numerator of my answer here. So if I try to factorize out cos power 4 and also sine power 4, I'll be getting cos square theta minus sine square theta multiply with cos square theta plus sine square theta. Okay, then divided by sine square theta cos square theta. Okay, then next step, what is the value for cos square theta plus sine square theta? So from the identity that we learned here, cos square theta and also plus sine square theta equals to 1. Okay, and now I'm having this cos square theta minus sine square theta divided by sine theta cos theta squared. Okay, then next step, how can we get to the final answer? Our final answer is having double angle 2 theta. And now we have to think about some formula that can change our fraction here, okay, into the double angle. So is there any formula that is related to double angle? If let's say I'm looking for cos square minus sine square, right, so you should know that there's one identity where cos square theta minus sine square theta is equals to cos 2 theta. Okay, so this is one of the identity lah. So if let's say you are not sure how to memorize it, then maybe you can refer to the formula booklet. But of course, if you refer to formula booklet, sometimes you will get you need to take a little bit of longer time, okay, to check and see which one should you use. Right. So for cos square minus sine square, I know that it is cos 2 theta. Then how about sine and cos? I have actually one formula about the sine 2 theta formula. So sine 2 theta equals to 2 sine theta cos theta. And if I try to bring it over, I will be having 1 over 2 sine 2 theta equals to sine theta cos theta. Okay, so you can see that for this one, I want to apply it on my numerator. Then this one, I want to apply it at the denominator. So if I try to combine all the results that I show you there, what do I get here will be, I will be having cos 2 theta at the numerator divided by half sine 2 theta squared. Okay, continue to simplify it. I still have cos 2 theta divided by 1 over 4, then sine square 2 theta. Okay, when I'm having 1 over 4, I will have a constant 4. Then for the cos 2 theta on top, I just keep it here. For the bottom, I'm having sine 2 theta and sine theta, sine 2 theta square, right? So I can separate it, become sine 2 theta and sine 2 theta. Then I rephrase it a little bit. You can see that I'm having 4 multiply with cos 2 theta over sine 2 theta. Then over 1 minus sine 2 theta. So why do I need to separate it by something like this? Because of I realize that there's a multiple the multiplication of 3 function here. Alright, then if I try to simplify what I get here, then basically you can see the answer is out. Cos over sine, you are having cotangent. 1 over sine, you'll be having cosecant. And this is the answer on the right hand side. Alright, yeah. So this is how we do part A lah. Then let's continue to part B. Okay, so next, let's solve the equation of cotangent square minus tangent square equals to 5 secant 2x for this range of the x. Alright, so first of all, let us combine let us substitute the result that we proved in part A into this part. And in part A, we have proved that cotangent square minus tangent square can be written as 4 cotangent 2x, then cosecant 2x. Equals to 5 secant 2x. Okay, and to solve this equation, for me, personally, I will want to make it into cos and sine function first. Okay, so for cotangent 2x, right, I can make it become cos over sine. Then for cosecant 2x, you can make it become 1 over sine. Okay, then equals to 5. Then secant 2x is also 1 over cos. Okay, then when you see that everything is in terms of sine and cos, right, I want to move all the number to one side, where I'm having 4 over 5. Then move all the trigo to the other side. Okay, then from here, you'll see that sine over cos is actually tangent. And then you're having tangent x multiplied with tangent x, you're having tangent square x equals to 4 over 5. Alright, then to make the square disappear, you have to take square root. Okay, so you're having plus minus 4 over 5 square root. Then after that, to solve this equation, you need to get the basic angle. It should be tangent inverse, and then I only consider the positive value, 4 over 5 square root. Okay, because the basic angle, we always assume that it is from the first quadrant. Therefore, we will always put it as a positive value here. Right, so if you didn't do any careless mistake, by right, your basic angle should be 41.8 degree. Just to double confirm, yeah, this one is in degree form, right? So it should be 41.8 degree. And then, I made another careless mistake just now. Do you aware where is it? For this one, when we're having sine 2x divided by cos 2x, the tangent that you get should be tangent 2x as well. Yeah, so this one should be tangent 2x as well. Okay, and then our basic angle is 41.8, and we have to go through the quadrant to get the answer for this equation. And then how many quadrant I need to go through? I need to know how many quadrant I need to go through to get the final answer. All right. Okay, this is the diagram that I'm using all the while. Okay, I'm having theta 180 minus theta, 180 plus theta, then 360 minus theta. Okay, then let's go back to our question just now. They are saying that x is between 0 to 90. But when after we found the basic angle, we need to find out the answer for 2x first. So to find the 2x, we need to go through the quadrant, right? And we need to know how many quadrant I need to go through. Therefore, I need to change the range for this one first. So x is from 0 to 90. Therefore, 2x will be from 0 to 180. That means when I go through the quadrant later, I need to go through 0 to 180, which is the first two quadrants. Okay, then now you ask yourself, I'm looking for tangent, positive and negative also I want to accept, right? In the first quadrant, tangent is positive, so I want to accept the answer from here, which is the basic angle, 41.8. After that, for the second quadrant, I also want to accept the answer, although this is tangent negative, right? But I also want to include the answer with tangent negative. Therefore, the answer from this part will be 180 minus the basic angle. It will be 138.2. After that, we will divide all our answer by 2. Okay, then if you divide by 2, you'll be having 20.9 and also 69.1. Alright, yeah, then you have to take note, yeah. when I have this answer, right, 41.8 and also 138.2, it is basically not a final answer yet. Therefore, when I write out in one decimal place. But when I press the calculator for the final answer, I'm actually using the long value for the 41.8. Okay, because it is not the final answer yet at this stage. Therefore, you have to keep the original long value divided by 2, then only you get the 20.9. Alright. Yeah, so this is how we solve question number 8. Alright, so question number 9. With respect to the origin O, the point A, B, and C have position vector given by this. Right, then the line L passes through B and C. Find the vector equation for L. Right. Okay, so we are having a line that passes through the B and also the C. Let me label them first, B and C. Okay, to form the vector equation of a line, the general formula is R equals to A plus TP. And A means the passing point, then P means the direction of the line. Okay, then T is a value, okay, that just keep it as a constant term. Right, so the A here, passing point, for this particular question, I'm having passing point B and also passing point C. So I have more than one passing point can be replaced in the formula, can be put in the formula. And after that, for the direction, you can use either the direction from B to C or from C to B also can. Right, so for me, I need to find out the BC first. I'm using BC as the direction of the line. Okay, so P is equals to BC. BC means BO plus OC. BO will be -1, -3, and also +2. Then OC is 2, 1, -3. 2, -1, and also 3. Okay, then from here, when you simplify, you'll be having 1, -4, and also the 5. Okay, this is the direction of the line. Then I just need to rewrite it again into the vector equation form. So this is the vector equation. Right, so for vector equation will be R equals to A plus TP. So the A means passing point here. So I'm using this passing point, 1, 3, and -2, plus T, then P. P will be 1, -4, and also the 5. This is the direction of the line that I found out just now, right? Yeah, so this is how we write out the vector equation for the line. Then let's continue further. The point P is the foot of the perpendicular from A to L. Find the position vector of P. Okay, so let's have a look for the line again. Yeah, I'm having line BC. Okay, I have the point A, and then point A, if I draw a line perpendicular to the line BC, to the line L, so this is what we call as the foot of perpendicular, and this is basically the point P. And now they want us to find the position vector of point P. Okay, there's no specific formula that you can use here for me lah. Okay, I'm not going to use any specific formula, but I want to use some a series of steps, okay, that is easier to understand and to find out the P. Okay, so there's no specific short formula or one formula to straight away substitute the value to get an answer. There's nothing like that. All right. Okay, so what am I doing is I try to write out the position vector of P first, because the P is the point that lies on the line BC. Therefore, the position vector of P should be equal to the vector equation of the BC. It is because of, if you substitute one value of T inside the equation, then it will give you the passing point along the line. So if we successfully get the T for the point P, then we will get the position vector for the P. Alright. Okay, so I try to combine the vector equation become 1 plus T. Okay, because it is from here 1 plus 1T, right? Then 3 minus 4T, -2 plus 5T. Okay, so 1 plus T, 3 minus 4T, then -2 plus 5T. This is what I have for the position vector first, but I do not know what is the final answer for the OP yet, because of there's an unknown T here, right? I need to figure out what's the value for the T. Okay, to find the value of the T, I will want to use the concept or maybe the information where I know the direction of AP and BC are perpendicular to each other, right? So that means that if I find out the dot product for AP and BC, then basically it will be equals to 0. So this is what I plan to use. Alright, because I know AP is perpendicular to BC. So if I put it in the vector form, I should know that AP dot BC should be equals to 0. BC, I already have the answer just now in the first part, right? Now I need to find the AP. So second step, I need to get the AP first. Again, what is the how to get the AP? AP means AO plus OP. What is your AO? OA is this one, 1, 2, 0. AO will be -1, -2, and also 0. Then plus OP. And what do I get from here? -1 plus 1 equals to 0. So you're having a T. -2 plus 3, you get a 1. And 0 plus all this, you have -2 plus 5T still. And this is my AP. Okay. Then now, like what I told you just now, I want to apply the concept or the formula where AP dot BC equals to 0 because the lines are perpendicular to each other. What is my AP just now? T, 1 minus 4T, then -2 plus 5T. What is the direction of the BC just now, or the vector BC? We have found it out in the first part, right? It should be 1, -4, and also the 5. And I let it equals to 0. Okay, so x multiplied with x. So t multiplied with 1, you get a t. Y multiplied with 1. Y multiplied with y. So you're having -4 times 1 is -4. Then -4 times 40 will be having 16t positive. Then the z times z. So 5 times 2. 5 times -2, you have -10. Then plus 25t. And it is equals to 0. Okay, try to simplify all the t together. You will be having 42. 42t equals to 14. And therefore, your t is equals to 14 over 42, which is also equivalent to 1 over 3. And now you already successfully get the value for the t here. You can substitute it back into the OP position vector to get the answer for OP. Alright. So let's continue from here. What is the OP here? I will be having 1 plus t. Then 3 minus 4t. And also -2 plus 5t. Okay, so please try to figure it out. By right, if you didn't do any careless mistake, it should be 4 over 3, then 5 over 3, and also -1 over 3. Then if you prefer to write it out in the IJK form, then you can just keep it in IJK form. 4 over 3i plus 5 over 3j, and also -1 over 3k. Alright, yeah, so this is how we get the position vector of the peak. Okay, then let's continue further. Part C, right? Now, they are saying that the point D is the reflection of A in L. Find the position vector of D. Again, try to imagine the line again one more time. Just now, we are having this one. Then you're having the point A. Then you have the point P. If I try to put all the vector in the coordinate form, right, the A will be basically 1, 2, 0. The P that we get just now should be fraction 4 over 3, then 5 over 3, and also -1 over 3. And now they say there's a point D is the reflection of A in the line L. Reflection of A in the line L means what? Means that you're having the line L as the mirror, okay? Then your A is reflected through the line L as a mirror, then you get a point D here. Alright, so it is still 90 degree basically. And then the distance from A to P is also same as the distance from P to D because it is a reflection, alright? Line L is a mirror. So when you reflect the A over here, you'll get a D. And let's say D, I don't know what's the coordinate, I put it as X, Y, and Z. So from here, you can see very clearly that point P basically is the midpoint of AD. Okay, yeah, so I'm using the Cartesian, the coordinate form, geometric coordinate form to show the answer. It is because of I feel that this is easier compared with the vector method. Alright, so P is the midpoint of AD. We are using coordinate geometry to solve it, yeah, midpoint of AD. Okay, so what's the coordinate of the P that you get? You're having 4 over 3, then 5 over 3, and also negative 1 over 3. Okay, that equals to midpoint of, sorry, I make a careless mistake again. This one is a D, midpoint of AD. I will be having 1 plus X, because I don't know what is the X coordinate for the X, for the D, right? So I just put it as the X divided by 2. Y will be 2 plus Y divided by 2. And also 0 plus Z divided by 2. Okay, then of course you have to compare X coordinate with the X coordinate and see what we get. 4 over 3 equals to 1 plus X over 2. And try to solve it here. You'll be having X equals to 5 over 3. Then same thing happen here. You try to compare Y with the Y coordinate. So 2 plus Y over 2 equals to 5 over 3. Okay, bring the 2 to the other side, then minus 2. Then the value of Y that you get should be 4 over 3. Then lastly, compare the Z with the Z coordinate. I'm having 0 plus Z divided by 2 equals to negative 1 over 3. And what's the value of Z that we have? So Z should be equals to negative 2 over 3. Alright, so we successfully get the value for X, Y, and Z. But for this question, they're asking for the position vector of D. And for me, I will want to write it out again in the vector form. Therefore, the position vector of D will be OD. It is equals to 5 over 3I plus 4 over 3J minus 2 over 3K. Right. Yeah, so this is how we solve the question number 10. We are given a differential equation and also some initial value. Then they want us to solve the differential equation of obtaining a relation between X and Y. So just solve the differential equation. Alright, so first step, let us try to separate our variable first, all the Y to one side, all the X to the other side. From this original differential equation here, because the dy is on the left hand side and it is a numerator on the left hand side, therefore I want to keep all my y here, all my x on the right. I have sine 4y originally, then I want to divide it by sine 2y because on the right hand side originally I'm having sine 2y also, right? So I bring it over, become divided, then keep the dy. Then for the dx, I want to bring it to the right hand side, and if I try to rephrase it, it will become sine 3x multiplied with the x and multiply with the x. Alright, from here you can see very clearly that we have successfully separated our variable. Then let's start the integration. For left hand side, sine 4y divided by sine 2y, you cannot just really simplify the angle directly, right? You have to do something so that you can make it into a pattern that you can integrate directly. Sine 4y and sine 2y, they are basically a double angle for each other. So let's recall back a double angle for sine 2y first. Sine 2y, the double angle formula should be sine 2x, the double angle formula will be 2 sine x cos x. Okay, but now for this question, I'm having sine 4y. If I change this one become 4y, what will happen to my angle inside? So just now 2x become x and x. Therefore, 4y will become 2y and 2y. Okay, I want to replace this in my numerator on the left. I will be having 2 sine 2y cos 2y divided by sine 2y. Then when you look at this one, basically you know that you can cancel off the sine 2y and sine 2y. And your equation become much more easier because if you left only cos 2y on the left. Yeah. Then after that, how about for the sine 3x? Multiply with the x. Okay, so this is actually a product of the two functions here. And then we want to integrate the product of two different type of function, or maybe the product of the two function. Basically, have to apply integration by part. Okay, so for the integration by part, the formula for integration by part is basically this one. Integrate u dv, where it is the question, equals to uv minus v du. Okay, then we need to decide which part of our question is u and which part of our question is integrate dv. And we have a rule here. It is actually LIATE. Okay, so L means all the log and ln function. I means the inverse trigo, such as tangent inverse or sine inverse or this inverse trigo. A is algebra like x, x squared, or maybe the number 3 and so on. Trigo means all the trigo function like sine, cos, everything. E means exponential form of the function. Alright, if in your question, right, there's one group that is located at the higher position, it will be the u. If let's say it is at the lower position, then it will be the integration of dv. So let's have a look for our integration here. I want to focus on the right hand side here. Okay, x is basically algebra. Sine 3x is basically trigo. And x is at the higher group. Sine 3x is at the lower group, right? And what we are going to do now is we try to let u equals to x. Then integrate of dv equals to the integration of sine 3x dx. Alright, so we let this one equals to our question. So we decide our question, which one is u and which one is integration of dv already. Then you can start the process. For u equals to x, you differentiate it and you get a 1. For the integration part here, you try to integrate it. Integrate 1 dv, you get a v. Integrate sine 3x, you'll be getting negative cos 3x divided by the differentiation of the 3x, you get a 3. Okay, then again, I will not put any plus c here yet because it is not the end of the integration yet. I will always put it at the last step only, right, after I complete all the integration in the equation. Okay, then now let's continue further. For this left hand side, 2 is a constant, so you just copy it. Then I want to integrate cos 2y. What do you get if you want to integrate cos 2y? Integrate cos, you'll get a sine 2y. Then you differentiate the 2y here, you'll get a 2, and you have to divide it by the 2. Alright, then equals to, I'm done with the integration on the left. Then let's focus on the right. I'm using the black color here. Now, according to the integration by part formula, I want to have uv. What is my u? U is the x. What's the v? V is this one. So if you combine u and v together, then you rephrase it again, you'll be having negative 1 over 3 x, then cos 3x. Okay, then minus v du. So I copy minus integration of v is this one, negative 1 over 3 cos 3x. Then du, where's your du? Du is equals to 1 dx, right? So du is equals to dx. Okay, on the right hand side, you'll be having sine 2y. Then on the left, you continue the integration on the left because it haven't completed yet. Okay, For me personally, I prefer to take out all the constant before I integrate it. So negative 1 over 3 become positive 1 over 3. And now, what do I get if I integrate cos 3x? If I integrate cos, then I will get a sine. So sine 3x, differentiate the angle 3x, we get a 3. So sine 3x divided by the 3. And now there's no more integration sign here, right? Therefore, I put it as a plus c at the back. So you can see that I only add the plus c at the very last step. I complete the whole integration. Okay. Then now, to get the answer, to get a particular solution, of course, you need to get the value of the c, right? But maybe before that, let me write out all the equation again. Alright, how can I get the value for the c? I have to use the initial value provided by the question. X is pi over 2, y is pi over 12. Okay, so when x is equals to pi over 2, and then y is equals to pi over 12. Let's substitute them into the equation and get the constant c. For sine 2y, I'll be having sine pi over 6 after I simplify it. For negative 1 over 3x, x is pi over 2. Then cos 3x is cos 3 pi over 2. Plus 1 over 9. Sine 3x means sine 3 pi over 2. Then plus c. What's the value for sine pi over 6? It is 30 degrees, so half. What's the value for cos 3 pi over 2? Cos 3 pi over 2 will give you a 0. So if you want, you can maybe make a small note for yourself. This one is basically a 0. Then what is the value for sine 3 pi over 2? Sine 3 pi over 2 will be equals to negative 1. Okay, so if I rewrite my answer again here, this term is a 0, this is a negative 1, so I'm having negative 1 over 9. Then plus c. And from here, I will get the value for the c, right? What's the value for c? You should be getting 11 over 18. Okay, then again, they are asking for the equation that relate x and y, right? So you just need to rewrite your answer one more time with the value of c included. And you will be having this sine 2y equals to negative 1 over 3x cos 3x plus 1 over 9 sine 3x plus 11 over 18. Okay, so this is the particular solution for this differential equation. Alright, okay, then let's continue further to part B. Now they say that y is between these two values, yeah? Find the values of y when x equals to 0. Okay, so let us rewrite again the answer that we get in part number 1. They said when x equals to 0, what's the value of the y? Substitute them into the equation. I'm having sine 2y equals to, this part will become 0. This one is also 0. Then it is equals to 11 over 18. Then I get the basic angle first. This is something like you want to solve the trigo equation. So as a basic angle, it is sine inverse 11 over 18. Okay, so what do you get for sine inverse 11 over 18? You'll get your answer 0.657 in terms of radian. Okay, then to get the answer for 2y, you need to think about the quadrants. Alright, we are having sine 2y equals to 11 over 18. And it is equals to 11 over 18. And then how many quadrants should I consider? Alright, so let's have a look for all this again. All, sine, tangent, then cos. Then we're having the basic angle, pi minus basic angle, pi plus basic angle, 2 pi minus the basic angle. Okay, then for this question now, we are looking for the answer of 2y, right? In the question, they said y is between 0 to pi over 2, which is 90 degrees. And I'm looking the answer for 2y now. Therefore, I have to consider the quadrant of 0 to pi. Multiply everything by 2 lah. So 0 become 0 to the pi for the 2y. That means when I go through the quadrant, I need to go through the first two quadrants for the answer and see whether I want to accept the answer or not. Looking for sign positive. In the first quadrant, is it sign positive? Yes. So I want the answer from this part, which is the basic angle, 0.657. Then again, sign is positive. In the second quadrant, is it sign positive? Yes, also, right? That means I also want to accept the answer from this part. It will be pi minus the 0.657. Then, of course, our final answer must be the y. Divide all your answer here by the 2. Then, if you simplify it, you will get 0.329 in 3 significant figure. Another value will be 1.24 in 3 significant figure. Okay, and just a reminder again, all the basic angle here, right, they are not the final answer yet. Therefore, when you write it out in your calculation, you can write out short. But when you are pressing the calculator, please press it as long as possible to get the most accurate answer. Alright, yeah, so this is how we solve question number 10. Okay, so question number 11. The diagram show the curve. Okay, and then the curve has a maximum point at M where x equals to a. Show that tangent to a equals to negative 4a. Okay, we are having the maximum point at M. Then they want us to find out the x coordinate of the M, which is the maximum point. So to get the maximum point, you need to apply dy dx, right? You need to find the dy dx and you let dy dx equals to 0. Then from there, we can get the x coordinate for the M, and we can continue to prove that A fulfills this equation. Alright. Okay, so let's start. Let's have a look for the question first. We are having the product of two functions in the equation of the y. So I'm having y power x, also x power half sine 2x. This is two brackets. There are two brackets here. So for applying the differentiation, you need to apply the product rule. So for me, what I do is I remember the process. Okay, so for product rule, I copy the first bracket, differentiate the second. Differentiate sign, you get cos 2x. Then you have to differentiate the 2x here, you get a 2. So this is what you have for copy the first bracket, differentiate the second. Now copy the second bracket, differentiate the first. So copy the second bracket, differentiate the first is pull the power half in front, copy the x, power minus 1 become negative half. Okay, so from here I'm having 2 square root x cos 2x, then plus 1 over 2 square root x sine 2x. Okay, then after that, at maximum point, I will let dy dx equals to 0. Then I try to move my equation slowly. I'll be having negative 2 square root x cos 2x, sorry. Then 1 over 2 square root x sine 2x. Okay, then I want to group all the 2 square root x together. Then I'm having negative 4x. Okay, then for sine 2x and cos 2x, I also group them together as a trigo, right? So I will be having sine 2x over cos 2x. When you simplify sine 2x over cos 2x will be equals to tangent 2x equals to negative 4x. And this is the equation that we get when we let dy dx equals to 0 to find the maximum point. Therefore, it also means that the value of A fulfills this particular equation because A is the coordinate, x coordinate for the maximum point M. And this is how we prove it. Then let's continue to part B. For part B, they want us to show by calculation that your A is between this value and we have to apply the sign change method. Let the equation on top become the function of A. I'll be having tangent 2a plus 4a. You move everything that you proved just now, right, to one side and make it as a function. And now I want to substitute the value 0.9 and also the value 0.95 into my function. and get the value. 2 times 0.9, 0.9. Then the second value here is 2 multiplied with 0.95 plus 4 multiplied with 0.95. Okay, then you just need to press calculator a little bit to help you. By right, this answer should be negative 0.686. Then the second value should be 0.873. Yeah, when we want to prove this, right, basically you need to know that the value is not important. What I want to look at is the sign. I must have one positive sign and one negative sign in my answer. So you can see here very clearly, right, this is a sign change. Alright, so since sign change can be seen between these two values for the function, and therefore there's the root is between 0.9 to 0.95. Okay, this is how we get answer. And then a reminder, because for this equation, right, it actually involves the trigo. So when you want to press the calculator, make sure that your calculator is in the radian mode. Because all the value here, the 0.9 or whatsoever, all these belongs to the radian, the angle in radian. Yeah, so this is how we get the part B. Then let's continue to part C. Okay, so for part C, they want you to show if a sequence of value given by the iterative formula, this one, converge to A. Okay, when you see this kind of question, right, basically you just need to rephrase your answer from iterative formula to the original question, original equation, or from the original equation, try to prove and get this one. Okay, so for me, personally, I will start from the iterative formula. I directly start from here. I feel that this one is easier to apply it here. Okay, so first I move the 2 over. After that, I bring the tangent inverse for x. Then I'm having pi minus 2x. Okay, so next step, I get the tangent inverse over become tangent pi minus 2x. Okay, then after that, if let's say you don't know how to simplify this one, right, you basically can use the compound angle formula or the addition formula for tangent A minus B. We are looking for A plus minus B, but we are looking for the minus, right? The formula is what? The formula is tangent A plus minus tangent B divided by 1 minus plus tangent A and also tangent B. This is the formula for the addition angle in tangent. Right, so from here you can see that I'm having the addition formula. Okay, tangent pi minus 2x. So tangent pi minus 2x, your A will be the pi, B will be the x, the 2x, okay? Alright, so let us substitute and expand it. I will be having tangent pi minus tangent 2x, then divided by 1 plus tangent pi and also tangent 2x. Okay, so from here, you need to know that tangent pi is equals to 0. So I'm having 4x equals to negative tangent 2x divided by 1. And eventually, you can see that I successfully get the original equation that we have in the first part. Okay, converge to A. Therefore, you have to substitute it back into the equation, not the equation y. I think I did mention the equation y just now, right? It should be the equation that fulfill for the A. Alright, so this is what we want to prove. Okay. Alright, then let's go for question number 4. Alright, so let's go for question number 4. Now they want us to use the iterative formula to calculate A correct to 4 decimal places. Then give your result in for iteration for 6 decimal places. Wow, there are a lot. Okay, let us start. Maybe I try to write out the iteration formula first. Yeah, I'm having x n plus 1 equals to 1 over 2, then pi minus tangent inverse for xn. Okay, so for this question, right, they didn't give me any initial value. So for the x1, you can take any value that you like, but don't be too far away from 0.9 and also 0.5. For me, I'm taking the midpoint, which is 0.925. Of course, for you, you can use any value that you like, all right? Okay, then how can I get the x2? To get the x2, basically you substitute your initial value, 0.925, into the iterative formula. 4 times 0.925. Then from here, you will get the answer. Okay, then to make our life easier, of course, we prefer to press it into the calculator form. Okay, then what can we do here is, let's try. I'm having something divided by 2, so I put it as a fraction first. Then the bottom part is a 2. The top one will be pi. So where's the pi? Pi minus tangent inverse. So tangent inverse 4x. So 4, then x, and close bracket. Okay, and before you use the calculator here, again, double confirm and see whether it's your calculator in the radian mode. Right, so once it is ready and you already key in the formula, let's use calculator and help us for the answer. Press calculate. The first value is 0.925, so 0.925. And the answer that I get is this one. Please make sure that you keep your answer in 6 decimal places. They did mention here, right? 6 decimal places. And you should have 917380. Okay, then after that, for the value of x3, you need to repeat the process. And now, please press calculate again. Then key in your value from x2. Because you're using the previous value, they estimate the next one. Right? So key in the value of x2 in your calculator. They ask you already, what is the value of the x? So please type in 0.917380. Then press equal sign. And you get this one, 918425. 0.918425. Okay, then let's continue for one more iteration. Same process, press calculate, then key in 0.918425. Then you press the equal sign again, then you get 918281. 0.918281. Okay, and again, if you're not so sure when to stop, then every time, please double check your answer. According to this question, they're asking for answer up to 4 decimal places. So you check the 4 decimal places answer. For this one, you get 0.9174. Then the next one, you'll get 0.9184. Then the x4 will be 0.9183. And none of these values are repeated yet, right? Therefore, you have to continue to get the answer until you are having 2 values in 4 decimal places repeated. Then I need to continue now because I don't have any repeated answer for 4 decimal places. So press calculate again. Then type in the value previously, 918281. 0.9182 and 81. Press equal sign. Then we get 918301. 0.918301. Then double check this one. Oh, you get already 0.9183. And for me, I want it to be safe. I will usually do one more extra iteration. So I press the calculate again, key in 918301. Press equal sign. Then you get 918298. Okay, so x6 is 0.918298. Again, double check the 4 decimal places answer. It is also 9183. That means the value of the a or the root will be 0.9183, correct to 4 decimal places. Alright, yeah, so this is how we solve this question 11, and this is already the last video, last question for this video. Thank you very much for watching the video.